Assalamualaikum and hello everyone. In this video, we're going to learn a new chapter, which is the second last chapter for semester 2, which is amino acid. So here we're going to look at the general structure of alpha amino acid, and we will give the name according to the IUPAC nomenclature, define the term Zwitterion and isoelectronic point, and last but not least, what we're going to look at the structure of a given amino acid in acidic, basic, and at isoelectronic point, ataupun this is what we call PI kita lah. Okay, so what is actually amino acid? Amino acid is a compound that contains both an amino group and a carboxyl group. So maknanya pada the same carbon attached to it, we have our carboxylic acid and we do have our amino ataupun amino group kita ni lah. Okay, so this is the basis of it. Okay, so carbon kita ada 4 bond. Carbon tu satu dia bonded to another hydrogen, and another one could be bonded to anything. So yang G ni is any general, it could be any atom lah. So dia kata different G group, maknanya different substituent will give the unique characteristic of the amino acid. So for example, if G ni we're going to substitute dengan H, so we're going to call it glycine. Kalau methyl yang attach pada sini, kita panggil sebagai alanine, and so on. So here is actually the common name, tapi this is the common amino acid, but this one you don't have to memorize pun. You should be able, contoh dia bagi structure ni, you should be able to name ataupun give the name IUPAC nomenclature. So let's look here. So how do we name it? Because we have two different group, ada carboxylic acid dengan amino. So carboxyl akan we give the parent name. Okay, and then the amino group ataupun the functional group amine kita ni will be as substituent. So kalau dia jadi substituent, dia nama amino. For case of alanine ni, so how do we name it? Tengok how many carbon is there. So kita akan start pada yang C double bond O tu. So we have carbon kan dekat situ, so that will be number 1. So we have 3, so dia jadi propanoic acid. Tapi pada carbon number 2, we have our methyl. Methyl pula amino. So there are 2 amino propanoic acid. So dia kena rapat lah. So B pula, kita tengok how many carbon. Start dengan yang carbon double bond O, we have 3 carbon as well. And carbon 3 ni ada OH pula. Okay, so how do we name it? Parent dia masih lagi propanoic acid, but then we have 2 different substituent. Okay, so kalau NH2 ni, the name of substituent dia adalah amino. Kalau OH adalah hydroxy. Dulu of substituent akan tengok the first letter. So amino lah dulu. So dia akan jadi 2 amino 3 hydroxy propanoic acid. Question C, D and E, I believe you could do it yourself. Okay, so now let's look for question F. So how about question F ni? So let's count. We have how many carbon? We have 6. So kalau 6, maka dia akan jadi hexanoic acid. But then pada carbon number 2 and 6, we have substituent, which we have identical substituent. So dia akan jadi di, tapi di apa? So make sure write down the name as well, ataupun the number, sorry. Jadi 2,6 diamino. Okay, so now let's look for question G. We have 2 of our COOH. Tadi ada 2 amino kan? Tapi this time around the carboxylic acid is the parent. So how do we name it? Count how many carbon. So we have 4. So dia akan jadi butane dicarboxylic acid. Okay, so since the name kita ni adalah amino acid itself kan, so kita kena tulis lah, we have the presence of amino pada carbon number 2. So dia ada 2 amino di hadapan. So that's it, the last of naming. Now we're going to look at for the case of Zwitterion. Zwitterion is a natural compound that contains both positive and negative charge. So as we can see, kita carboxylic acid ni dapat neutral kan, tak ada apa-apa charge kan, but actually it's a Zwitterion, and it's formed when the proton from the COH is donated to the nitrogen. So actually what happens is that the electron here, dia akan act as a base where dia akan attract hydrogen lah. So bila akan attract hydrogen, akan form a new bond. Lepas tu sebab dia dah donate the electron to the hydrogen, so that's why ada positive charge. Okay, and then, so what happen next? The OH bond ni akan break. Okay, and the electron will move to oxygen, sebab oxygen is more electronegative atom. So that's why we have our negative charge pada our COOH tu akan jadi COO minus. And actually amino acid ni selalunya, walaupun kita nampak dia neutral macam ni, but actually it will exist in terms of Zwitterion ataupun dipolar ion kita ni lah. So how are we going to draw it? Dari NH2 jadi NH3 plus, COOH jadi COO minus. So let's look here. So glycine kita ni, so how does it work? So NH ni nanti dah akan ambil the hydrogen from our OH, so akan jadi NH3 plus by donate electron towards the hydrogen. So the CH ni macam mana? CH ni kita tuliskan sahaja. Next is our COOH. So what's the difference is that the hydrogen tu dia akan form nitrogen dah ambil hydrogen kan? Okay, and the electron being donated to oxygen, sebab tu ada negative charge. And this is actually in equilibrium. Okay, so sebab tu kita akan buat reversible arrow. So now let's look for the case of valine. Carbon hydrogen sama sahaja. Yang COOH apa akan jadi? Dah donate ataupun dah dissociate kan. So jadi O minus. NH2 pula dia akan accept hydrogen from our OH. So akan jadi NH3. Tapi setelah donate electron to our hydrogen, so akan ada NH3 plus. Okay. So this is actually the Zwitterion lah. Walaupun selalunya kita nampak carboxylic acid in terms of neutral kan, yang COH dengan NH2, usually it exists as Zwitterion. And it's actually amphoteric. Amphoteric tu maksud dia adalah both acid and base. Okay, so how does it work? So bila the presence of acid where pH is less than 7, dia akan act as a base. So how does it work? Dia akan accept a proton to form cation. So acid ni we're gonna add H+. Kita akan reaction dia dengan our Zwitterion. It's not our neutral charge. So I'm just gonna draw an example here from our glycine. So remember, presence of acid is that we're going to add H+. So what happen next is that H+ ni dia nak react dengan O- lah, sebab dia nak apa ni, yang opposite charge. Dia tak nak lah yang sama charge dengan dia kan. Okay, ataupun next thing you're going to look at, base ni akan accept a proton. So maknanya O- ni akan ambil the hydrogen itself. So bila dah ambil the hydrogen, so O- ni is not O- lah. Dia akan jadi OH sebab O- dah campur dengan H+. So we're going to remove the minus charge. So this is actually our product, which is cation, sebab kita ada positive charge on nitrogen. Okay, so that is actually in the presence of an acid, dia akan act as a base. So macam mana pula kalau acid H+, kalau presence of base, we're going to add OH minus where pH more than 7. Okay, so dia akan act as acid bila dalam basic condition. So kita akan tambahkan dengan OH minus, tapi which part yang akan react? Dia tak nak react dengan our O minus ni sebab sama charge kan. So apa yang dia nak react dengan our NH3 plus. So how does it work? Is that Zwitterion act as an acid. So kali ni dia akan donate proton. So yang mana satu yang akan donate proton? So ada dua. Nitrogen ni akan donate the proton to our OH minus ni to form our H2O. So yang hydrogen yang being removed is actually from our nitrogen. Hydrogen takkan donate dia punya hydrogen. So what happen is that our product is we're going to remove one of the hydrogen from our nitrogen. Sebab dah hydrogen tu dah being donated kan dengan water, to form water. So I'm just going to remove this one hydrogen and I'm going to remove this charge. So nitrogen memang ada 3 bond to form a charge 0. So bila dia dah donate dah punya proton, we're going to form an ion sebab adanya negative charge pada O minus ni. Okay, so we have look bila the pH dia less than 7 dengan more dengan 7. Tapi sekarang ni kita nak tengok the pH at which the amino acid exists primarily in neutral state ataupun zero net charge, no net charge. Okay, apa maksud no net charge ni? Ataupun senang nak kata Zwitterion lah, primarily exists in Zwitterion. Okay, no net charge ni maknanya charge dia is equal to 0. So kita tengok Zwitterion ni positif dengan negatif 1 kan, so jadi 0 lah. Cation ni charge dia positif 1, anion charge dia negatif 1. Tapi kalau Zwitterion dia punya overall charge dia adalah 0. So the pH at which the amino acid exists as Zwitterion is what we call isoelectronic point ataupun PI. So kita senang tengok example lah dekat sini. So we have our alanine. Alanine ni so I'm just gonna draw dulu. How does we gonna draw amino propanoic acid? Ada 3 carbon buat double bond OOH dengan NH2. So we have our 3 carbon. So this is our alanine. So tapi ini belum lagi Zwitterion form. Okay, Zwitterion form is that when the NH2 akan accept the hydrogen and the yang OH tu kita donate dia punya hydrogen. Okay, so what I'm gonna draw kalau in terms of Zwitterion dia akan jadi NH3 plus. Jangan lupa sebab dia dah donate the electron to hydrogen. Yang oksigen ni dah buang hydrogen, so jadi O minus. So this is what we call our Zwitterion lah. So kalau senang nak ingatkan kamu, kalau what happen bila Zwitterion ni from our NH2 akan jadi NH3 plus, our COOH akan jadi COO minus. So this is what we call our Zwitterion. So sekarang ni in terms of Zwitterion ni barulah kita boleh reaktkan dia dengan pH dia is equal to 2 ataupun 12. So pH equal to 2 is less than 7, which makes it acidic condition. So bila dia adalah acidic condition, we're going to add H+. So which species yang kita akan ambil yang neutral kosong tu ke yang Zwitterion, we're gonna take the Zwitterion. So Zwitterion akan react dengan H+. So what would happen? Dia akan react dengan yang mana? Dia akan react dengan yang O-, yang opposite charge. So we're gonna combine it to form OH. Itu adalah pH dia is equal to 2, which is acidic medium. So kalau PI dah buat, okay, pH is equal to 12 is actually a basic medium. So kalau basic medium kena tambah OH minus. So we're gonna add our Zwitterion dengan OH minus. In this case, what we're gonna form is that OH ni dia tak nak dengan negative charge, dia nak positive charge. Tapi how does it work is that OH minus ni akan form H2O sebab dia akan ambil hydrogen from our acid. So dah akan ambil hydrogen from where? Dia akan ambil hydrogen from our NH3 ni lah. Yang O double bond OO minus mana ada hydrogen. So what happens is that I'm just gonna remove the number 3 dengan remove the charge. Okay. So that's the answer when the pH is equal to 12 ataupun basic medium. So in past year question, what they always ask you is actually dia akan bagi the name of your amino acid as well as the IUPAC nomenclature. And then they ask you to draw the structure when it's at PI ataupun pH is equal to 3 atau pH equal to for example 10. So what you're going to do is that for your carboxylic, for your amino acid, you're going to draw the Zwitterion. So kalau yang Zwitterion ni, this is actually, kalau kamu nak buat macam ni, this is actually when the PI lah, isoelectronic point, where usually amino acid exists as Zwitterion. Okay, tapi kalau pH dia tu, dia tak akan bagi tahu dia adalah acidic medium ataupun basic medium. It's just that you have to know lah, pH less than 7 is acid, pH more than 7 is a base. So based on that, you have to do the the equation lah, the relevant equation ataupun the relevant product. So untuk example 2 and 3, you should try it yourself.